Hello students. Now we are going to discuss density. Density of D block elements. How density varies. First density formula is density represented by rho. Density formula is molar volume by molar mass by molar volume. Molar mass by molar volume. So relation between density and the mass is directly proportional. Density and volume is inversely proportional. Rho is inversely proportional to V. Rho is directly proportional to mass. And a 3D series element left to the right. Density of 3D elements left to right. What will happen? In general periodic table, left to right size decreases, right? If size decreases, if size of an element decreases, the space occupied by the substance, the space occupied by the element decreases. That is nothing but volume. Volume is nothing but how much space it occupies. So size decreases means volume also decreases. If volume decreases, density increases. So density of 3D elements increases from left to right. Density of 3D series element increases from left to right. Because size decreases and absolutely molar mass increases from one element to the next element. Scandium, titanium, vanadium, from one element to the next element, mass increases. Okay, this is the general trend. If you apply the general trend in copper and zinc, what do you get? Density of zinc is greater than copper. Density of zinc is greater than copper because from one element to another element, density should increase. We are expecting density of zinc will be greater than density of copper. But what is happening is the experimental result is density of copper is greater than zinc. Why? Why this is happening? So we need to use the idea in copper, zinc. Copper atomic number 29, zinc atomic number 30. So here configuration is 3d10 4s1. Here 3d10 4s2. Number of unpaired electron is 1. Here number of unpaired electron 0. We know very well number of unpaired electron is directly proportional to metallic bonding. Bonding between the atom. Bonding between the atom is force of attraction. If the force of attraction is strong, see one atom. If the force of attraction between the atom is strong, atoms will come close together. If atoms comes close together, volume decreases. If volume decreases, density increases. So bonding between the atom increases, volume decreases. Bonding is directly inversely proportional to volume. So number of unpaired electron. If it has more number of unpaired electron, metallic bonding will be strong. If metallic bonding is strong, volume will be low. So here we have one unpaired electron. Here there is no unpaired electron. So here metallic bonding is strong. If metallic bonding is strong, volume will be volume of copper is lesser than volume of zinc. Why? Because in zinc there is no unpaired electron. Metallic bonding strength is very low compared to copper. Here one electron is responsible for metallic bonding, but here there is no unpaired electron. So if volume is inversely proportional to density. So density of copper is greater than density of zinc. in our exam they may ask question whether the variation which one is highly denser, zinc or copper. According to general rule is the density of zinc should be greater than copper, whether it is observed or not. If not, what is the reason? They may ask like that. You should use this idea, this concept and all. You should use the number of unpaired electron, metallic bonding, then volume. Relate all the things. In zinc, as there is no unpaired electron, metallic bonding strength is low. If metallic bonding strength is low, volume will be larger. Use the idea properly, then try to answer. Okay. So discussing all those things, we are going to discuss the next important concept, that is oxidation state. A very important one. D block element shows variable oxidation state from D block element shows variable oxidation state from +1 to +8. It can show the oxidation state from +1 to +8. That is very, very important. Sorry. Most common oxidation state of 3D series element is +2. It is ready to lose 2 electron. All the elements present in 3D series. Common oxidation state. Element which has highest number of oxidation state. Highest number of oxidation states. Is manganese. It can exhibit oxidation state from +1 to +7. So 7 possible oxidation states. Element which has highest possible oxidation state, value wise which is highest, osmium and ruthenium. This two belongs to iron group, and ruthenium, osmium. This two can exhibit highest oxidation state of +8. Not in all the compounds, specific in some compounds it can exhibit osmium tetraoxide. It's a very good organic reagent. In organic chemistry, it's a very good reagent, osmium tetraoxide. It is a here osmium exhibit +8 oxidation state. And now we need to account the reasons why D block element shows variable oxidation state. The reason for variable oxidation state is availability of vacant d orbital. We know d orbital means is diffused orbital from an atom nucleus. So orbital get s orbital, p orbital, d orbital. D orbital is very far away from the nucleus, so it is diffused. Electron present in the d orbital can easily escape from the atom, whereas electron present in s and p, they are bound towards the nucleus. The force of attraction existing between nucleus and sp are very strong when you compare to d. So the electron present in d can easily escape. So electron present in d orbital can easily escape. The reason is the orbital is diffused. Why it is diffused? It is far away from the nucleus. If d is diffused, f will be highly diffused. The orbital f orbital is well exposed to the outer space. And one more reason, energy difference between n-1d and ns orbital is small. 3d, 4s. This is small. As this is small, electron present in 4s also can accommodate, can participate in bonding. Electron present in 3d also can participate in bonding. Bonding means it can lose, as they are metal, they can lose electron. So these are the things you should aware of it. And copper +1 in aqueous solution, copper +1 is unstable. So what you will do is copper 2+ and copper. Here +1 oxidation state, from plus 1 to 2 plus, from plus 1 to 0. So 2 copper is needed. In aqueous state, copper plus 1 is unstable. So to undergo disproportionation reaction. Why disproportionation reaction? In reactant side, single oxidation state. Element having only one oxidation state. In product side, one get oxidized, another one get reduced. Single element, same element undergo oxidation as well as reduction. A reaction in which a same element undergo oxidation as well as reduction is known as disproportionation. Cu plus 1 in water undergo disproportionation reaction. Okay. Next. In what way they will ask question? We already seen manganese can exhibit 7 possible oxidation state from plus 1 to plus 7. Now if we calculate the oxidation state of manganese here, the answer will be plus 7. As fluorine or minus 1, we have 7 fluorines. So 7 fluorine means 7 minus. To MnF7 is neutral. To make it is neutral, manganese should exhibit plus 7 oxidation state. But MnF7 does not exist. MnF7 does not exist. They will ask why. Why Mn plus 7 does not exist? Even though manganese having plus 7 oxidation state, the compound does not exist. The reason is, see, we have manganese atom, fluorine, 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 fluorine. So 7 fluorines. Fluorine atom, fluorine atom, fluorine atom, fluorine atom, fluorine atom, fluorine atom, fluorine atom. See, around manganese, 7 fluorines we are having. They will repel each other. This repulsion is known as steric crowding. Steric crowding is very larger in MnF7. That's why MnF7 doesn't exist. Even though it is possible oxidation state, the compound doesn't exist. Why Cu plus 1 doesn't exist in water? Because it is unstable. So it is highly unstable. So it undergo disproportionation and forms Cu2 plus and Cu. Why MnF7 doesn't exist? Due to steric crowding. Whereas this can exist, KMnO4 minus. If you calculate the oxidation state of manganese here, you will get plus 7. How to calculate this? First we need to take the total charge. Total charge is minus 1. What is the total charge present here? That is total charge minus 1. And we have manganese and oxygen. Manganese plus 4 times of oxygen equal to minus 1. We are going to calculate the charge of manganese. So let it be X plus 4 into oxygen. In compound, oxygen exhibit minus 2 oxidation state. So X minus 8 equal to minus 1. X will be plus 7. KMnO4 minus, MnO4 minus is stable compound. The structure is MnO4 minus. This is the structure of MnO4 minus. Permanganate ion. Permanganate ion. See here. Yes, around manganese 7 atoms are there. But here manganese only 4 atoms. Steric crowding decreases. If steric crowding decreases, stability increases. The repulsion between the surrounding atom will be small. Here the repulsion between the surrounding atom is large. But this all exists. CrF6, chromium exhibit plus 6 oxidation state. In chromium trioxide, chromium plus 6 oxidation state. This all exists. Next, compounds of transition metal. Next, we will compare with the help of oxidation state. We can say whether which nature is predominant in the compound. If the metal ion exhibit higher oxidation state, then the compound will be predominantly covalent. Covalent nature will be more. This is according to Fajon's rule. Fajon's rule is an 11th standard concept. Here the thing which is very important is, if charge increases, charge of cation increases, covalency increases. So even though it is ionic compound, MnO, MnO2, Mn2O7 are ionic compound, there some percentage of covalence will be there. And how the percentage varies from one compound to another compound, it is determined by the oxidation state. If the metal ion exhibit higher oxidation state, their covalency will be more. If the metal ion exhibit lower oxidation state, it will be predominantly ionic. Predominantly ionic. How we can relate this? MnO, manganese exhibit plus 2 oxidation state. MnO2, manganese exhibit plus 4 oxidation state. Mn2O7, 2 times of X plus 7 times of minus 2 equal to 0. Why 0? Total charge is 0. Why total charge is 0? Because the compound is neutral. So 2x minus 14 equal to 0. X equal to plus 14 divided by 2. X equal to plus 7. So plus 7. So here plus 2, here plus 4, here plus 7. Positive charge increases, higher oxidation state. Plus 2, plus 4, plus 7. Higher oxidation state increases, covalency increases. So this will be predominantly covalent than this. This will be predominantly covalent than this. Covalency will be more absorbed in Mn2O7. This will be predominantly ionic. If covalency increases, if the compound is ionic, it will be soluble in water. Ionic compound will be readily soluble in water. If the predominantly if it is covalent, sparingly soluble or less soluble in water, because the covalency nature increases, less soluble in water. It's not very important things. We should relate with oxidation state. If it is higher oxidation state, predominantly covalent, according to Fajon's rule. Okay.